My name is Madison Jones. I'm the engineering design lead for Axlebox Innovations and SafeTech. Our team of engineers work closely with Skyfire's consultant group and drone experts. The project was to support Skyfire with the development of one of their drone platforms using additive manufacturing.
So the biggest things for us were making sure that these drones were rugged enough to be deployed into wildfires. We're not talking about flying into flames or anything like that, but you can get 60, 70 mile an hour winds around a fire. And honestly, most of the commercial off-the-shelf drones just can't fly in those conditions. So that was kind of our starting point. We took weather data from over 800 locations in California and factored that into how we were designing the aircraft. So it's got a lot of air pass-through, so it's not really affected by wind. We've also designed things to be weather resistant, and those were really big deals because there's obviously a lot of water, there's a lot of stuff coming from airplanes that are being dropped on fires, and so these things needed to be able to operate in those conditions.
They wanted a mid-body to have exceptional strength and stiffness as well as thermal resistance, and therefore Axlebox's team compared material sets from different service providers, and we determined that HTN CF25 from Essentium was the optimal material. HTN CF25 is a high temperature carbon fiber reinforced nylon, has about 25% carbon fiber, and when compared to PA603 CF or other carbon fiber reinforced nylons, it has the highest heat deflection temperatures as well as strength and stiffness. In addition, PACF from Essentium was chosen to produce the side covers for the mid-body. Skyfire requested that the covers also have carbon fiber reinforcement, but lower strength and stiffness so that in a crash it would likely fail before the mid-body, and that helps the drone be more field serviceable.
When we went into this, we were sort of naive in thinking that 3D printed parts were just for prototyping, and what we found out, particularly with Essentium, is there are a lot of really high endurance, high temperature, high strength filaments that we can get now that actually make these production ready parts. And because you can actually print them in such high quality on these machines, they don't look 3D printed. So using Essentium materials, we were able to find the right filaments to fulfill the parts that we needed. We were able to print them quickly, and we were able to make design changes that made it more efficient using that material so that we could use less material and make it stronger. The cool thing about additive manufacturing is we can make a design change on a part and have a new one printed and in the air within a couple of hours. And that's pretty cool to be able to make a change and you don't have to ship it off to some manufacturer to cut out of metal or whatever. We can actually make the change, put it on the printer, have it come out, put it on the aircraft, and we're up and flying. In some cases, those became final parts. In other cases, they were just test parts. But it was cool to be able to actually think of something, draw it in a CAD program, and print it out, and then it's right there within a couple hours.
We want people to see what Essentium can do for public safety and defense. We're actively in the process of making our initial run, the product, and it's all coming off of an HSC with y'all's material. We took ideas, we prototyped it, we showed it to the customer. The customer didn't like it. We made a change, and we did this in weeks. We didn't do this in years. There's no other way you could have done that without additive manufacturing, and the speed and the time, and then essentially be delivering product within a year.